guys, we're back and we are on lesson 13. Lesson 13 is going from ratio tables to equations using the value of a ratio. All right, so here we're going to go ahead and we're going to read this. And it says, Liddell is mixing a special shade of orange paint. He mixed 1 gallon of red paint with 3 gallons of yellow paint. Based on this ratio, which is a 1 to 3, comparing red to yellow, which of the following statements are true? So now these statements are in your student workbook on page 131. If you don't have that, I wrote them down on a piece of paper, so I'll give you guys an opportunity to go ahead. So the first one reads, 3/4 of a gallon mixed would be yellow. Excuse me, 3/4 of a 4-gallon mix would be yellow. Every 1 gallon of yellow paint requires 1/3 of red. Every 1 gallon of red paint requires 3 gallons of yellow paint. There is 1 gallon of red paint in a 4-gallon mix of orange, and there are 2 gallons of yellow paint in an 8-gallon mix of orange paint. All right. So now I want you guys to try to figure out whether or not that those statements are true. All right, if you actually went ahead and tried to figure out whether or not they were true, the only ones that were true were the first one, the second one, the third, and the fourth. The fifth one was not true because it did not hold the ratio. It was not an equivalent ratio. All right, so there wasn't. It wasn't equal to the original ratio that was given. All right. So whether the original ratio was given, it was 1 to 3. All right. But if we flip that, and that was comparing red paint to yellow paint. But if we flip that and compare yellow paint to red paint, it would give a 3-to-1 ratio. All right. So now we're going to go into exercise 2. And exercise 2 is on page 132 in your student workbook. So if you'll notice that in exercise 2 that we're still comparing red paint, and then they use the letter R. And then we say yellow paint and they use the letter Y, and then they give you a relationship. All right. So that R and that Y, those are what we call variables. Variables is just a letter used to represent something we don't know. Okay. So those would be where we would create our equations from. Okay. We would use the variable to represent something we don't know. So if we look at the first one, it talks about a relationship. Now the relationship is the ratio. What did I do to one number in order to get the other? So 3 times 1 is going to give us 3. So that's how we would get 3 gallons of yellow paint. All right. So for every 1, we would put the number 1 in here. For every 1 gallon of red paint, there is 3 gallons of yellow paint in order to make this orange mixture. Okay. So then we would go ahead and do the same thing. So now instead of us getting the amount of yellow paint in order for us to know this, we need to know what's happening here. So we can create an equation to say y is equal to 3r. And notice there's 2 variables in there. They just represent whatever it is. So when we're working with variables, all you have to do is, if they give you the number for r, then you just take the r out and you plug it in, but you also have to put multiplication. So this right here is multiplication. So y is equal to 3 times the letter r. We don't know what y is. We don't know what r is. They just represent a placeholder, right? So when we go through the table, sometimes the table will give us what r is, and sometimes the table will give us what y is, and then we'll just work backwards or forwards in order to get it, okay? So in this case, we need to figure out what y is. So I'm going to show you, I'm going to say that y is equal to 3 times, and now we'll use this little dot to represent multiplication as opposed to the letter x, because the letter x also serves as a variable, and we'll learn that later on as we'll go through our lesson. All right, so y is equal to 3 times 2. All right, so 3 times 2, so y is equal to 3 times 2, which is 6. So in this case, we will put 6 here. So then over here, the relationship would say 6 is equal to 2 times 3. All right, then we would go ahead and we would do the same thing for the next numbers, but in this case, we're still using the same equation, but The difference is that they give us y, but they don't give us r, so we got to work backwards. We got to see, well, what do we do to 3 in order to get 9? Okay, so this one we say that 9 is equal to, in this case, 3r. Okay, so because this is multiplication, in order for me to get this r by itself, because that's my goal, is to find out what this letter r is. See how the letter y, when we did it the first time, y was by itself on one side of the equal sign. I want r on one side of the equal sign, and then I want the numbers on the other side of the equal sign. So I want to social distance here. So right now we have to social distance letters from numbers. In order for me to social distance letters from numbers, in this case, I must divide both sides by 3. So when I do that over here, this 3 cancels out, leaving me with the r by itself is equal to 9 divided by 3, which is 3. So r, in this case, we would substitute the number 3. Then we would go ahead and we would do the same thing as we did before. So we would go ahead, so instead of it being 9, we would use the number 12. And again is equal to 3r. Remember, we want to social distance that r, so I got to get rid of that 3 by dividing on both sides. So then r divided by 3 is just r, because 3 divided by 3 is 1, and then 12 divided by 3 is 4. So in this case, r is equal to 4. 12 is equal to 3 times 4. Then we would work the other way in order to figure out what y is equal to. So in this case, instead of us putting y here, we would leave y. We would keep y social distance, okay? And then take 3, multiply it by 5. 3 times 5 gives us 15. So here, 15 is equal to 3 times 5. All right? So you want to make sure that you keep the relationship according to what was original, and then go from there. Make sure if you're using variables, you want to social distance those variables.